If you roll some drops of water in fumed silica, this hydrophobic coating protects the droplet from other water. It can't merge with other drops. But if you just take fumed silica and mix it in a blender with water, it'll form tiny micro droplets of these hydrophobic drops of water. These tiny drops are weird. They flow kind of like a liquid and kind of like a powder. But here's where it gets interesting. What would happen if we put a sodium chunk in the dry water? Okay, so we've got our ball of sodium. Let's see what happens when we put it in the dry water. Okay, 3, 2, 1. Oh, there it goes. Now this was interesting and a little unexpected. It didn't explode. I've never seen it just burn like this. What's burning here is the hydrogen gas, so no explosion. But let's try it again just to make sure it's not a fluke. Pop it in. Again, nothing happening. When nothing happens, that's the scariest thing because that means you have to walk up to it after and not know if it's going to explode. Okay, there it goes. Oh! Okay, something happened that time. So what happened? Why did it explode this time but not last time? So the first time all that happened was a bunch of fire. Now I'm pretty sure that this would have heated up the water, and when you heat up water, it lowers the surface tension of the water. But what if we reduce the surface tension? Well, an easy way to reduce surface tension is just to put some soap on it. So let's see what happens when we put soap on it. Soap greatly reduces surface tension by disrupting the hydrogen bonds between water molecules, especially at the surface. As a result, when we put it on dry water, it just melts it. That's what's happening here is these tiny drops are combining together because they can't stay spherical anymore. Hydrophobicity doesn't work very well when soap is involved. So I'm guessing what happened is we reduced the surface tension enough that in the second reaction there was able to get a lot more liquid water involved with the reaction.